Hello friend, it's another beautiful day. Thanks for joining me here today. If you haven't subscribed to this channel, please do so for more updates. Yes, today we'll be talking about resistor color codes. How you can determine the value of a resistor from its colors. Before we go straight away to that, we'll first of all look at the codes assigned to those colors, because when we talk about codes here, we are simply talking about these numbers, these digits assigned to various colors you can see on a resistor. So this is just a table that I've drafted showing different colors and the numbers or values attached to it. Yes, when you look at this table, you have a color here, and this other section here is showing the various numbers attached to it. That's the first and the second digit, because yes, here we are targeting 4-band resistors. I know we'll be talking about other types later on. Here we have the multiplier, and here we have the tolerance. So that is it. So in a few seconds I will be projecting the full list on the screen that you can see for yourself. Alright, friend, you must have seen the list of those colors and their codes on the screen. Now let's look at the formula you can use to determine the resistance of a 4-band resistor. A 4-band resistor. Yes, you just check the image on screen with their colors. I'll be right back. Okay, friend, you must have seen. So the formula used here, when you see these 4 color bands on a resistor, one thing you have to first of all know is that here with those resistors, in most cases the tolerance will be a bit having a slight difference in the distance, in spacing. In most resistors you see, the tolerance will have a bigger spacing than the normal colors. You take a physical resistor, looking, I'm saying like this 4-band, you discover that the tolerance will be having a much space than the spaces between the normal colors. So the formula here is simple. The very first color, you write out the digit. Then the second color, you write out the digit. Now the third color will be the multiplier, of which the multiplier now, I wish you multiply in power of tens. Yes, multiply in power of tens. And the last will be the tolerance, of which we will just write out. So what changes here will be the multiplier in the way you write it out. Let's take for instance, if the third color was let's say red, I know that you take um, 10 times 10 2 times. You multiply 10 to the power of 2, 10 times 10, which will give you 100. But in this case, you are not supposed to write out the other figures. What you need just to copy out are the zeros. You know that first, those other figures in the other figure 1. Okay, let's take a look at this one here. So the first one, let's say let's find out what this resistor will really be, the resistance. Okay, like I said, looking at our formula of here, the first one you write out the digit like I showed on the color code table. Brown here represents 1. So what do I do? Let me write out the 1. Let me write out the 1. Let me write it clearly. This is your 1. This is your 1 written. Okay, black here, the corresponding number is 0. So let's write out our 0. Let's write out our 0 here. 0. Okay, we know that the third digit is the multiplier. Okay, and the corresponding number to red, because here we have the third band. The third band there is red, which corresponds to the number 2. If you check back here on the table, you see that red is 2. So that is it. So let's come back. Okay, so now the third band is red, which is 2. So we take 10 to the second power. That is, you take 10 times 10. 10 times 10. 10 times 10 will give us 100, like I said. But in this case, we don't need this first digit 1. Sorry, we don't need this first digit 1. So just copy out the 0 there. So here we will write out 2 zeros. Okay, now the tolerance band, the fourth band here, the tolerance band, which is the fourth band here. The fourth band here is gold. Yes, it's gold. It's gold. And on the table we have gold to be positive, -5. Let's check it out. Okay, so this is gold. You run through the column. Yes, the tolerance for gold here is positive, -5. This is it, positive, -5. Then you just copy it out. Right, positive. Right, positive, -5% is in percentage. Sorry. So if you were to write out the value, it would be something like the resistance is measured in ohms. That is it. So this is the value. This is the value. This is the value. 1000 ohms. And the resistance here, this tolerance here shows just a fluctuating percentage. Yes, the resistance can either increase by 5% or it drops by 5%. That's why you see it being rated in positive, -5%. So it can either increase by 5% or drop by 5%. So when you measure, even with your multimeter, we discover that the value could sometimes be closer to or lesser a bit, or sometimes you could just give the exact value. Like this 1000 ohms, you could measure and it give you 1000, or you could measure and it gives you around 900 and something, or it gives you 1000 and something. So that is it. So which is also equivalent if you want to use another derivative unit. You will have a 1 kilo ohms. You can still write it out like this. That's 1 kilo ohms. Now kilo normally will represent 1,000. So that is it, friends. So on the screen, we'll just look at it. Yes, just check your screen. The very next image that will be coming next will be showing you the real resistor, the actual appearance of the 1K resistor with all its colors. Okay friend, thanks for watching. See you other times.